Draw a diagram to represent the bonding in silicon chloride. Write down the chemical formula of the compound. So the first thing to do is to work out what type of atom silicon is and what type of atom chlorine is. By that I mean, is it a metal or is it a non-metal? So we can use the periodic table to help us with this. So this red line on the periodic table represents the divide between metals and non-metals, with metals on the left-hand side and non-metals on the right-hand side. So if we find silicon, it's over here, and therefore it's a non-metal, and chlorine is also a non-metal. And what that means is that the bonding that takes place between silicon and chlorine is covalent, because only covalent bonding occurs between two non-metals. That will help us when drawing our diagram. The second thing we need to do is work out whether it's going to be a single, a double, or a triple covalent bond. And to do that, we need to draw the electron shell diagrams of both silicon and chlorine. So if we start with silicon, it's got an atomic number of 14. That means there will be 4 electrons in its outer shell. So there'll be 2 in the first shell, 8 in the second, and 4 in its third and outer shell. Remember, we only need to draw the outer shell when we're doing covalently bonded diagrams. Then if we draw chlorine, it has an atomic number of 17. So it will have 7 electrons in its outer shell, and that's because there's 2 in the first shell, 8 in the second shell, and 7 in the outer shell. And I've just drawn those as dots to distinguish between the crosses from silicon. So what we can see is that chlorine needs to share 1 electron with silicon in order to form 8 electrons in its outer shell and have a full outer shell of electrons. If it does this with silicon, so let's just imagine we have our chlorine here, and it shares 1 electron with silicon. So there'll be 1 here from chlorine, and we'll take this one away and pretend it's being shared there. We can see that silicon will end up with 5, whereas our chlorine would have its full outer shell of 8. Therefore, in order for silicon to bond with chlorine covalently and also get its full outer shell, it must bond with 4 chlorine atoms. So to draw that, here's a silicon, and we're going to draw almost like a Venn diagram structure with 4 chlorines. Remember to have that overlap. And then silicon has 4 electrons, it will share 1 with each chlorine atom. And chlorine has 7, but it will only share 1 with its silicon. And then the other 6 remain unshared. And then if we have a look at each chlorine, we can see there are 8 electrons in its outer shell now that it's shared 1. And if we look at silicon, there are also 8 electrons in its outer shell. So the next step then is to write down the chemical formula. We can see that there's 1 silicon atom and 4 chlorine atoms. So that's written as SiCl4, which is known as silicon tetrachloride. And just to mention that these covalent bonds are all single covalent bonds, as each atom has shared 1 electron. If they had both shared 2, that would be a double covalent bond, and if they had both shared 3, that would be a triple covalent bond. Thank you.